this video, we are going to learn about the conditional maxima and minima using the method of Lagrange multipliers. When to use this method? Imagine we want to find the maxima and minima value of the function but with certain condition. For example, we have the function that depends upon three variables x, y, z, and there is a specific conditions depending upon these variables, suppose g1 and g2. We need to find the extreme value of the function. Extreme value means maybe maxima or a minima under the condition g1 and g2. For example, we have the function x, y, z. We need to find the extreme value of this function, but under the condition x plus y plus z is equal to a. Means we need to find the value of x, y, z at which it has a maximum value in the product form, but when you take the sum of all these three variables, that is equal to a, where a is greater than 0. Or we need to find the extreme value of this function 2x plus 3y plus z under the condition that x square plus y square is equal to 5 and x plus z is equal to 1. Moreover, observe that in both the example, whenever the condition is defined, that is always contain a equality sign. In the first case, equality is over here, and even if you read this statement, this is a condition for this function. Similarly, in this case, equality involved in two equations. It means these are the two conditions imposed on the variable x, y, and z. Step to solve with the Lagrange multiplier. Suppose we have the function that depends upon x, y, z and represented by small f, and condition is represented by small g, that is depending upon three variable x, y, z. First step, we need to construct an auxiliary function, that is a capital F is equal to given function plus lambda times of condition. Here lambda is known as Lagrange multiplier and it is an undetermined parameter. Then we will find its a critical point, means a stationary point, by taking the derivative of function with respect to each variable, and that derivative is basically a partial derivative. It means we need to take the partial derivative of function with respect to x, y and z, put it as equal to 0 in order to find the critical point. After that you will get an equation and compare these equations in terms of lambda and try to compute the relation between x, y, z. Then use the given condition to find the values of x, y, z. Substitute the obtained value of x, y, z into the original function in order to get the extreme value, and that is the last step. For example, we need to find the extreme value of this function x, y, z when x plus y plus z is equal to a. How to solve this one? So first step, we need to identify the function and the condition. Function is x, y, z. When you need to find the condition, make sure condition is equal to 0 form. Means a g is a function that depends upon the variables, like in this case x, y, z, that must be is equal to 0. Condition is x plus y plus z is equal to a. We write this as x plus y plus z minus a is equal to 0, and the function is x, y, z. Step number 1, write the auxiliary function, that is capital F is equal to small f plus lambda times of the condition, that is x, y, z plus lambda times of x plus y plus z minus a. Step 2, find the critical points of this auxiliary function, that is partial derivative of function with respect to x, then find the partial derivative of function with respect to y and partial derivative of function with respect to z, then put it as equal to 0. Now what is the partial derivative of this function with respect to x? Keeping y and z as a constant, its derivative with respect to x is yz plus its derivative with respect to x. This lambda is as it is, its derivative is 1 its derivative with respect to x is 0. Simply we are getting here as a 1. Put it is equal to 0. From here we have lambda is equal to minus y times of z. Similarly, calculate the partial derivative of function with respect to y, that is equal to xz plus lambda times of 1. From here put it is equal to 0, and from here we have lambda is equal to minus x times of z. Now calculate the partial derivative of function with respect to z, that is xy plus lambda times of 1. Put it is equal to 0. We have lambda is equal to minus xy. We are getting a 3 equation where in a first equation lambda is equal to the negative of yz, in second negative of xz, in third negative of xy. Using these 3 equations, find the relation between x and y and z. From equation 1 and 2, we have minus yz is equal to minus xz. This implies y is equal to x, because this z is get cancelled with z and negative with a negative. From second and third, we have minus xz is equal to minus xy. So this negatives get cancelled with the negative and x with x. We have z is equal to y. As x is equal to y is equal to z, it means x is equal to z. With the help of this one, we can say that x is equal to y is equal to z, ultimately x is equal to z. From here, the relation between x, y, z is obtained. Now use the condition. Condition is the sum of these three variables is equal to a. Using condition, that is x plus y plus z minus a is equal to 0. Substitute the value of y in terms of x, z in terms of x. Simplify this. This is a 3 times of x minus a is equal to 0. This implies the value of x is equal to a by 3. If the value of x is equal to a by 3, and from here we have x is equal to y is equal to z, so this implies all the values are is equal to a by 3. It means the critical point in this case is a by 3, a by 3, a by 3. At this point, what is the function value? At this point, the function value is a by 3 into a by 3 into a by 3. That is equal to a cube by 27. So, extreme value of this function with this condition is equal to a cube by 27. Let's take another example. In this case, we need to find the extreme value of this function with these two conditions. Now we have two conditions, it means there are a two multiplier. Here, first step is again identify the function. Function is depending upon three variables, that is equal to 2x plus 3y plus z. The first condition g1 is equal to x square plus y square minus 5 is equal to 0. Second condition is represented by z2, that is x plus z minus 1 is equal to 0. In this case, rather than taking a one multiplier, we will take two multiplier in the auxiliary function. Auxiliary function is written as capital F is equal to given function plus lambda 1 times of first condition plus lambda 2 times of second condition, where lambda 1 and lambda 2 are the Lagrange multipliers. The auxiliary function in this case is 2x plus 3y plus z plus lambda 1 times of x square plus y square minus 5 plus lambda 2 times of x plus z minus 1. Now find the critical point. For that, take the partial derivative of function with respect to x. In this case, derivative is 2. This derivative with respect to x is 0. Its derivative with respect to x is 0 plus lambda 1 times of its derivative with respect to x is 2x plus its derivative with respect to x is 0. Its derivative with respect to x is 0 plus lambda 2 times of its derivative with respect to x is 1 plus derivative of z with respect to x is 0 and the constant term again derivative is 0. We have 2 plus 2x lambda 1 plus lambda 2. Substitute is equal to 0. Then find the partial derivative of function with respect to y. Here we have 3 plus lambda 1 times of, here the derivative of function with respect to y is 2y plus lambda 2 times of derivative of this term with respect to y is 0. Simplified form in this case is 3 plus 2y lambda 1 is equal to 0. From here we can extract the value of lambda 1, that is minus 3 by 2y. Similarly, calculate the partial derivative of function with respect to z. Its derivative with respect to z is 1 plus its derivative with respect to z is 0. It means lambda times of 0 is equal to 0 plus lambda 2 times of its derivative with respect to z is 1. Put it as equal to 0. We have lambda 2 is equal to minus 1. From here we have the lambda 1 value and from here lambda 2 is equal to minus 1. Plug in these two values over here. We have twice of 2x lambda 1 is 3 by 2y plus lambda 2 value is minus 1. From here we have 2 minus 1 is 1. This is minus 3x by y because this 2 is get cancelled with 2. That is equal to 0. This implies minus 3x is equal to minus y, or we can say that y is equal to 3x. Now we are getting the relation between y and x, that is y is equal to the 3 times of x. Now use the condition in order to find the value of x and y. As per these two conditions, the first condition is depending upon x, y. With the help of the first condition, we can extract its values using d1 is equal to 0 means x square plus y square minus 5 is equal to 0 and y is equal to 3x. We have x square plus 3x square minus 5 is equal to 0. This implies 9x square plus x square is 10x square is equal to 5. This implies x square is equal to 1 by 2. From here, we have x is equal to plus minus under root 1 by 2. After calculating the value of x, now we need to calculate the value of y and z. For that, use the given conditions. First condition is x square plus y square minus 5 is equal to 0 and the second is x plus z minus 1 is equal to 0. From here or from here, we can find the value of y, whereas the value of z is calculated from this condition, that is x plus z minus 1 is equal to 0. How to evaluate that? First, we will plug x is equal to positive 1 by under root 2. According to this, we can take the value of y either from this one or this one, that is equal to 3 times of x, that is equal to 3 by root of 2, and the value of z from this condition is equal to 1 minus x. It means in this case the z value is 1 minus 1 by under root 2. Similarly, calculate the value of y and z when x is equal to minus 1 by under root 2. In that case, the value of y is 3 times of minus 1 by under root 2, that is equal to negative of 3 by under root 2, and in this case the z value is equal to 1 minus of 1 by root 2, that is equal to 1 plus 1 by root 2. It means total critical points in this case we are getting at 2, and the critical points are 1 by root 2, comma 3 by root 2, comma 1 minus 1 by root 2, and the second critical point is when x is equal to 1 by root 2, in that case the value of y is minus 3 by root 2, and the value of z is 1 plus 1 by root 2. In the next step, we need to find the function value on these critical points. In our case, the function is equal to twice of x plus 3 times of y plus z. Now, what is the function value at this critical point? That is equal to 2 times of x plus 3 times of y plus z. This is equal to 10 by root 2 plus 1. Similarly, calculate the function value at the second critical point, that is 2 times of x, that is minus 1 by root 2 plus 3 times of minus 3 by root 2 plus 1 plus 1 by root 2. In this case, the function value is equal to 10 by root 2 with a negative sign plus 1. As you can observe, in this case, we are getting a two critical points. Suppose this critical point is A and this critical point is B. On the critical point A, we are getting this function value. On critical point B, we are getting this value. Even in this case, the function value at A is greater than function value at B. In this procedure, we are getting a two critical points and both act as an extreme point. It means where we get a maximum value, that point is called as a point of maxima. Similarly, where we get a minimum value, that point is categorized as a point of maxima. Hence, the point A categorized as a point of maxima and B as a point of minima.